तो शुरू करते हैं। एक सेकंड, ये मैं वो कर दूँ। एक सेकंड। क्वेश्चन आपको कौन से दिख रहे हैं? ये इधर ले जाओ। तो क्या दिखता है? तो ये दिख रहा है, और ये भी इधर ले जाओ। तो दिख क्या रहा है, मतलब बेसिकली आपको ये वाली स्क्रीन दिख रही है, तो इसको इधर ही रखो। फिफ्थ का क्लास क्वेश्चन से स्टार्ट करते हैं। 8 34 हो गए, 4 मिनट वेस्ट हो गए। अब ये बंद कर दिया और इसको नीचे करके सबसे पहले फाइंड सेंटर ऑफ स्टार। कुछ नहीं है, सिंपल सा ही लग रहा है क्वेश्चन तो। सेंटर ऑफ स्टार आपको ये 4 2 1 3 ऐसे देखा है। स्टार ग्राफ का क्वेश्चन है ये 4 2। तो फिर इसका सेंटर फाइंड करने के लिए बेसिकली देयर इज एन अनडायरेक्टेड स्टार ग्राफ एन नोड्स। कितने नोड्स लेबल फ्रॉम 1 to n। स्टार ग्राफ इट इज वन सेंटर एग्जैक्टली एंड दैट कनेक्ट द सेंटर नोड विद एवरी अदर नोड। Labeled from 1 to n, a star graph is a graph where there is one center node and exactly n minus 1 edges. अच्छा, n minus 1 edges हैं उसमें, ठीक है, that connect the center node with every other node, ठीक है. You are given at 2 edges where each e of I indicates that there is an edge between nodes in return the center of the node. तो 1 2 के बीच में आ जाए, 2 3 के बीच में आ जाए, 3 4 4 2 के बीच में आ जाए, 4 और 2 के बीच में आ जाए. आगे ऐसे भी हो सकते हैं, 0 हो सकता है, 5 हो गया, 6 हो गया. तो उसका सेंटर अपने फाइंड करना है. 3 6 भी हो सकती है, 2 हो सकता है. तो कुछ नहीं, हम किसी से भी स्टार्ट कर रहे हैं. अब कोई ना कोई देयर वुड बी कुछ एजेस होंगे, सम एजेस, some nodes which will come exactly once. Yes. Take two of such nodes. ऐसे कुछ दो nodes will take. We will take two of those nodes. For example, we took 1 and we took 4. And if we took 1 and if we took 4, then on performing, on going through all these edges, same distance, hmm, we would reach. Definitely, we would reach. Where we would reach at point where they converge. That would be the center. Yes. Basically, I am saying that from 4 we will go to all the possible. From 4 and 1 we will start iterating. And the moment we will receive a common node, we will stop and return. Okay. First of all, we have to create an adjacency list. So for creation of that adjacency list from this given edges, what we have to do? We will okay. For adjacency list, so adjacency list is basically vector of vec- oh my god, vector vector of int comma vector of int is basically an adjacency list, and for auto of size n. other size you don't know, na? For auto I belongs to edges. That is, for a particular edge, for 1 to 2, we would first get it dot first to it dot second. What we would do, auto brings it dot first to it dot second, we will make an edge. What does this mean? And yes, you know. What does this mean? This means that adjacency of it dot first equal to it. Why is this step needed? I was thinking about that. Is it a must? We have to find that comes at least once, only once. Adjacency of it dot second equal to it dot first. Basically, we got all of the adjacency of that will be counted. Yes, definitely. Of it dot second dot pushback. Because pushback dot push underscore back. Now what will happen is we have created an adjacency matrix, adjacency list. Now for each I would say, now I will iterate over for auto node belongs to edge. Node belongs to adjacency matrix. At one index there will be all those who are neighbors of it. But जिसकी भी सबसे ज़्यादा, the thing which has a maximum, oh wow, why would we have to do an iteration? The place which has the maximum number of, yes, in max frequency equal to 0. If frequency means number of people, if adjacency matrix of that node की बात कर, of nodes नहीं, list of node, list of, for example, its index, yeah, no, we want its index for int I collaboration I less than n plus 1, you may say I plus plus uh, if adjacency of I dot size means the size of 2 is less than max frequency, अरे यार, is less than max frequency, then we can say that we must change it. Then max frequency equal to adjacency of I dot size. Okay, fine. Now max frequency is known. That is 2 will be known, 1 will be known, 3 will be known. Now provided that 2 is known, what would be the next step? Next step would be answer we have to store in the answer, and it will be 0, and we have to say answer equal to A. Now at last we will return that answer. This was pretty easy. this always creates the syntax I would have to convert, confirm how much time did I took. About 10 minutes. Let me go to Plot and let me close this. Let me go and ask. The N, what is N? It didn't know. For my, it was at this of white dot size. Why space on big? I don't think so. Syntax is pretty of IT dot first नहीं चलता इसमें and IT of zero and for this also I have to do IT of zero and it is IT of Radhe 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 uh, expected. Okay, some foolish mistakes. Now this runtime added, what does it indicate? For auto, but I am pretty happy that no such I less than equal to n or I less than n plus 1. It's the same thing. Is greater if it's greater than if max frequency less frequency should be different and answer should be different. But push back IT of 1. Why is this plus 1 required? I'm not able to think of it. Okay. Oh no, it was not edges dot size because of edges dot size. No, n was the total number of nodes. No, don't do this. First, at first I was thinking about this total number of nodes. Let me do this first, then I will try to find that out. Oh no 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 no. We can also do that. And because number of nodes, the number of edges plus one. That's why it is working. N was number of nodes only. So the solution was pretty correct only. Something from improve. Thanks a lot. Beat was less, so let me remove. And that completes the first question. Okay, we may go through solution once. What was best solution possible? One liner. Wow. Wow. Return that first equal to the solution. No, why? Oh, but no. Acha, this is a star graph. Oh my god. Let me for fun. Wow. I thought that this was a star graph. Okay, then it is not at all likely to be a, even a good expected situation. Now let us go to the next question. These are not at all needed. What I thought was is the time. Let me go to easy question next. Find if part exists in graph. Find if part exists in graph. Let me first go through. Find if path exists in the graph. There is a bidirectional graph with n vertices where each vertex is labeled from 0 to n minus 1 and inclusive. So this is a bidirectional graph where each vertex is labeled from 0 to n minus 1. Okay. The edges in this graph are represented as a 2D integer array edges where edges of I equal to ui comma vi. Hmm. Denotes bidirectional edge between ui and vi. Okay. Vi, you want to when there is valid path that exists from source to destination. From source to destination. Given from source to destination. Does there a path exist? Edges and so edges, source, destination, and region n. What does that n means? Oh, this means this n. For all the edges in adjacency matrix, we will push 0 to 1, 1 to 2, 0 to 2. That's it. And what is the next task? This would is n fine. Now, now the other task is to go from source to destination to find out that to find out whether a path exists from the source to a destination. What if the path does not exist? How is it possible that a path does not exist? If in the DFS of one, DFS of source, destination does not come. That's it. Okay. Now, how do we perform the DFS? Depth first search of this. Okay. Now let me check in the destination should be. I think probably a global variable because in destination. Now source would be changing, but destination would remain the same. Now this is destination equal to. Oh my god. Destination equal to des. Now what is the next thing? Destination. Full press. Okay, we will perform a DFS. Why DFS? We can make it bold. Of source. Source will be there, and so if a source is there, adjacency matrix can be made a global variable too because passing it all the time. Oh my god, passing it all the time is a tough task. So let me make it a global variable. Now source is given. Visited should also be there as a global variable or not. I think probably it should be a global variable also. Now, for a particular source, what we are doing is that we are performing GFS. Then we will first of all make it as visited. So visited of source equal to I might do what is that what it would do if source is not there. Source is not there. Yani, when return false, what can we say? As we visited, we visit it and for all of its neighbors. For auto, its neighbor belongs to adjacency of that source for all of its neighbors. For particular, if we take a 0, then 1 or 2. For that particular neighbor, um, if not visited, his source is not visited, then visit it. Then call DFS of that DFS of that neighbor. Now, if source equal to destination return to, now its answer would be it's not visited and we made a call and visited it, then we have to return true. Else we have to return false, then nothing is going to do. Now probably everything is done and just we have to call DFS source with nothing, probably yes. And this we have to return. Probably it is. Now now it is saying what's and go. Now I can tell you what's and. Now, this is and. Now that is fine, bro. Where's Claude? Now let me go. And this is probably correct. Yeah. Okay, okay. Nice. This was probably wrong. Everything is yeah, baby. Now 2 seconds is very very large for this question. 400 MB, very very large. Yeah. What is the solution? Okay. Now this alien clone graph is like this course schedule problem. Also a topological circle. What do you mean? Yeah. Minimum height trees. Now this is probably a good solution. Cheapest flights within K stops or minimum height trees. Now what's this question? Government changes. Now what the solution says, I will explain. Oh yeah, why I use it. The reason that in this towards is connected exactly one path. In other words, any connected graph is exactly that we given a tree and nodes n minus one and then area of n minus one edges where edges of I equal to. Then you get there is an undirected edge between the two nodes A and B. You use any node, the tree as the root. When you select the node as the root, the result has a height among all possible roots. Minimum height tree result a list of all MHT's root level. You can return the answer in any order. The result, the height is the number of edges. Okay, I understood. The question is simply saying that